Number 960, Rooftop PV and to install VRE Rooftop PV implementation plan. The government of Indonesia, in this case, the Ministry of Energy and Mineral Resources and EBTK and PT PNN support the development of rooftop solar power plants in Indonesia by issuing ESDN Regulation Number 49 of 2018 concerning the use of rooftop solar power generation systems, which opens opportunity for PLN customers to build rooftop PV on the roof of the building. PLN's support for rooftop PV development includes PLN supports rooftop PV by providing parallel facilities, creating a billing system to accommodate export-import offsets and provide credit deposit from solar PV consumers, provide sufficient and appropriate reserve margin to offset solar PV intermittent, continue to maintain the reliability and quality of rooftop PV consumers and the environment by maintaining a balance between local supply and demand, running a fair business scheme for customers and PLN. Challenges in developing roof PV. First, some of PLN's electrical systems are currently not ready to accept EBT due to oversupply due to decreased demand. Second, the entry of rooftop PV causes PLN to prepare a generator to be used as a buffer or follower, thereby increasing operating costs. Third, apart from generating buffers, the inclusion of rooftop PV can lead to the addition of other investments such as automatic generation control AGC, precise forecasting generation, automatic dispatch system, upgrading SCADA systems, and others. Fourth, grid code enforcement, which can incur additional costs for generator operations, both PNN and IPP. The implementation of rooftop PV in government buildings refers to Presidential Regulation 22 and 2017 concerning the National Energy General Plan ruling to install a rooftop PLTS of at least 30% of the roof area. To increase the use of rooftop PV for industrial customers and as a commercial building, referring to Minister of Energy and Mineral Resources Regulation Number 16 of 2019, Article 14. Second Amendment to Minister of Energy and Mineral Resources Regulation Number 49 of 2018 for the installation and construction of rooftop PLTS with the following conditions. First, PLTS on-grid roofs are subject to a capacity charge and are not subject to an emergency energy charge. Second, off-grid rooftop PLTS is not subject to capacity charge and the cost of purchasing emergency energy charge for rooftop PLTS for self-interest by non-consumers of PTPLN must comply with statutory provisions. PLTD dieselization program. PLN plans to reduce fuel consumption by implementing the dieselization program, which is divided into the following stages. First, interconnection of isolated systems to the grid so that the PLTD BBM these systems is no longer operational. Second, gasification and construction of gas generators, non-BBM. Third, converting PLTD to EBT generators and trying to use a hybrid scheme with batteries in isolated systems, where it is not possible to build transmissions for interconnection to the grid. In order to reduce the use of import-based fuels in the power generation sector, the utilization of PLTD generators will continue to be reduced in stages. The PLTD to EBT conversion program is one of the initiatives to reduce fuel consumption and increase generator cost efficiency, especially in isolated area and increase operating hours. Fueled generators will be replaced with EBT generators and EBT technology that will be used according to local energy potential. such as PLTS, PLTB, PLTBM, PLTAL, PLTP, and others. The PLTD conversion is part of PLN's effort to exploit environmentally friendly energy sources and explore local energy potential, as well as taking into account the potential for development and future electricity consumption in the region. The implementation method uses geospatial analysis, starting from mapping the distribution points of existing PLTD, mapping the potential for renewable energy sources in the region, which is combined with the potential for regional economic growth at the identified points. Of the approximately 5,200 units of PLTD engines installed in Indonesian territory and spread across 2,130 locations, they have the potential to be included in the de-dieselization program by converting to EBT generators, the implementation of which is gradually adjusted to the evaluation of energy availability and suitability, local and system requirements. In the early stages, the PLTD conversion program will be carried out in 200 locations, equivalent to plus minus 225 megawatt. In the early stages, PLTD to EBT conversion will be carried out for generating units with an age of more than 15 years, located in an isolated electricity system and with fuel consumption above 0.2738 liter per kilowatt hour. Some of the power plant locations feature the targets of the PLTD to EBT conversion program have not been operating continuously for 24 hours. This is due to the limited transportation of fuel oil and the condition of the generator engine, which is also that it must be operated ultimately with, of course, relatively high operating costs. In detail, the selection of the right PLTD location must include the following: identification of the PLTD location, analysis of supply patterns, peak load, and demand for electricity supply, information on demographic, economic, and market potential conditions as a basis for analysis of potential electricity demand at the location or electricity subsystem. The PLTD to EBT conversion program will be carried out in stages, and it is targeted that the PLTD conversion program will increase the capacity of EBT-based power plant by 20